Hey everyone, in this lesson we're going to talk about the carnitine shuttle. So why do we need carnitine? Well, carnitine is important in fatty acid metabolism. It aids in the transportation of long-chain fatty acids into the mitochondria for beta oxidation. Now, carnitine is derived from either our diet or it is biosynthesized, and it is biosynthesized from the amino acids lysine and methionine. If you want more information on this, check out my carnitine biosynthesis video. Now, the carnitine shuttle itself is required because the mitochondrial membrane is impermeable to long-chain fatty acids. I specify long-chain fatty acids because medium and short-chain fatty acids can pass through the membrane. So this is the main reason why we need the shuttle, is for long-chain fatty acids. So, if we think about the mitochondria is a double-membraned organelle. It has an outer mitochondrial membrane and an inner mitochondrial membrane. And deep within the mitochondria is the mitochondrial matrix. In between the two mitochondrial membranes is the intramembrane space. So it all starts with a long-chain fatty acid. So once we bring a long-chain fatty acid into the cytosol of a cell, it can be acted on by an enzyme known as acyl-CoA synthetase. This enzyme is located at the outer mitochondrial membrane, and what it does is it actually utilizes a couple of cofactors. It utilizes ATP and CoAsh. And what it does is it essentially adds a coenzyme A group to the long-chain fatty acid, and it activates the fatty acid. And once we have the fatty acyl-CoA, it can be acted on by an enzyme that's located within the outer mitochondrial membrane known as CPT1, or carnitine palmitoyl transferase 1. What this does is it actually removes the CoAsh from fatty acyl, or the fatty acyl chain, and it adds a carnitine to the fatty acyl chain. This allows it to enter into the intermembrane space. So once we have fatty acyl carnitine, that carnitine portion of the molecule will allow the fatty acyl chain to cross the inner mitochondrial membrane and enter the mitochondrial matrix. It does so through a transporter that's located within the inner mitochondrial membrane known as carnitine acylcarnitine translocase, or CACT. This allows the fatty acyl carnitine to cross the inner mitochondrial membrane, enter the mitochondrial matrix. Once we have fatty acyl carnitine within the mitochondrial matrix, it can be acted on by the enzyme CBT2, or carnitine palmitoyl transferase 2. This enzyme takes a CoAsh, and it actually removes the carnitine portion of fatty acyl carnitine. So it removes carnitine, and it adds a coenzyme A to the fatty acyl chain. So this gives us a fatty acyl-CoA and also regenerates our carnitine. So CBT2 is essentially doing what CBT1 does, but in an opposite direction. So once we have fatty acyl-CoA within the mitochondrial matrix, it can then undergo beta oxidation of fatty acids. We'll talk about this a bit more in a future lesson on fatty acid metabolism. Beta oxidation of a fatty acyl-CoA will give us acetyl-CoA as a product. Now, we also have a carnitine that's been regenerated, and it's within the mitochondrial matrix. But this carnitine can actually be pumped back out of the mitochondria and into the cytosol. It actually utilizes the same transporter, the carnitine acylcarnitine translocase, goes across the inner mitochondrial membrane, crosses the outer mitochondrial membrane, and enters the cytosol, where it can be used again as a shuttle or a carrier molecule for another long-chain fatty acid. Now, there's also another form whereby carnitine can actually be regenerated and brought out into the cytosol. So carnitine can actually be acted on by an enzyme known as carnitine acetyltransferase inside the mitochondrial matrix. What this does is it actually transfers an acetyl group to carnitine to give us acetylcarnitine. So carnitine gets acetylated to form acetylcarnitine. That acetyl group can actually come from an acetyl-CoA that has been generated from beta oxidation of the fatty acyl chain. The acetyl-CoA, after we've removed the acetyl group, will actually become CoAsh. So once we have this acetylcarnitine, it itself can also be pumped across the inner mitochondrial membrane through the same transporter, carnitine acylcarnitine translocase, and back out into the cytosol. So carnitine can be recycled into two forms. It can be recycled into acetylcarnitine and carnitine. And once we have carnitine back in the cytosol, once again, it can then be utilized to bring in more fatty cell chains into the mitochondria matrix for beta oxidation. So anyways guys, this was a lesson on the carnitine shuttle. I hope you found this video helpful. If you did, please like and subscribe for more videos like this one. And as always, thank you so much for watching, and I'll see you next time.